Another LED lamp. This one is again from eBay, and it's a little pygmy lamp. And the listing this came off was from a seller called Smart Shine. That's Smart understroke Shine. And they didn't offer them individually. You could only buy them as like from 2 upwards to 10. So I didn't want that many, so I bought 2. And unlike the other part of this order, which came from the UK, this one was shipped from China. So these arrived this morning, and it says 220 volt, 1.5 watt, warm white. And rather interestingly, apart from the 20,000 hour lamp life, it does suggest it's dimmable. It says UV shop, where it should say UV stop. It also implies it's greater than 100 degrees centigrade, which is quite disturbing for an LED lamp. And I'm not sure this symbol is. It shows little dots above a lamp. I don't know if it means it's breakable or something like that. Well, it's certainly, it almost implies to me that it's not breakable, but it is made of glass. It also helpfully says, without the drive power supply for new high pressure product, which doesn't even make sense. So here's the lamp, and I've measured it, and it came in at 2.5 watts, 12 milliamps, and that was at 249 volts, which is the current voltage tonight. And I have to say, the first thing I noticed about this lamp is the heat. It gets hot, and it's not that bright, he said, flinching as he touched it, and the end here, if you take it out and touch the end immediately, it gives you a burn because it gets that hot. And to me, that suggests, and here's a notepad, I'll doodle my guess here. I'm guessing that in the base of this is going to be a resistor. I think it's a resistive dropper. For that temperature, that's all I can think it would be. And if that's the case, then if you consider that the 12 milliamps times the voltage, which was 249, is 2.9 watts. So minus what it actually was, which was 2.5, would suggest that the actual dissipation from the LEDs is about half a watt, and which would give P equals IV, I equals P over V, V equals P divided by, it was 12 milliamps. This is just guessing. Going to give a voltage of about 40 volts across the LEDs, divided by about 3 volts. This is all just guessing. Up to 13 LEDs, I might be completely wrong. 13 or 14 LEDs, maybe it's a little cob inside. I haven't a clue. And the only way I'm going to find out is to open it. And I don't think that's going to be pretty, because this is glass sealed onto metal. So I think I've got 2 of them, so I'm going to sacrifice this one. Pretty sure that there's a resistor in here because, as I say, it's red hot. In fact, so hot that I wouldn't really want to run it continually at that temperature, because if the LEDs are getting that hot as well, then it's not really going to last that long. When I felt the temperature, it reminded me of the neon flicker flame lamps, which, because our voltage is higher, they tend to run significantly hotter than the typical ones you'd find in America, running on 110 volts. So there's a resistor. There's a really small metal film resistor. Guessing metal film, it's not very big at all. A disappointingly small resistor given how much power it's probably dissipating. Now, am I going to get access to this? It's a sort of plastic bung up the end of the lamp. Oh, and the lamp has just cracked, actually. That's interesting. Oh, it's a cob. So, is there a rectifier? Oh, you know what? They might just have LEDs in inverse parallel inside the cob. Okay, am I going to be able to get that out? So I should be able to actually do a more accurate test on this just by... I'm going to cut myself here shortly if I'm not careful. So this resistor is basically, this resistor is getting red hot. Really, you can't touch the end of that. And the other end of that resistor, which is tiny, it's really not rated for the power it's dissipating, it's actually going right up to the LED cob itself, so a lot of that heat will be going into that. I might just nip the bottom of that off. There we go. And I do want to nibble this away and get that cob out without lacerating my fingers in the process, although I suppose it provides entertainment for everybody else if I do that. I don't want to have to crack the super glue out. And yes, I have super glued bits of skin back together in the past when I've had horrible incidents involving sharp metal. Okay, it's getting closer. It is almost like a ceramic base. I don't know if it's actually glued into the glass. Let's try gently pushing it. No, it's just popped out, that's good. So here's the LED. Let's put it in the power supply, the bench power supply, and crank the voltage up. I can only go up to 36 volt on this. Hopefully it'll come on before then. What's the value of the resistor? Let's measure the value of the resistor. $6K. Okay. Power supply. Let's see what voltage I've got this set for. I'll set it way down to about, we'll start off, I'll limit the current to about 10 milliamps, because I think it's just an ordinary LED chips in this. So let's wind the current way down. Yeah, around about there. And let's stick this on and see what happens in there. Just strip that wire. If I can strip that wire, that's quite a thin wire, it's below the setting of the strips. And I'll turn the voltage up. So that's me at 6 volts. I reckon there might be about 40 volts across that, so this might not actually get that far. I could be wrong, could be completely wrong, because it is a rather unusual load. I'm up to 17 volts. 22 volts. I think that could well be 40 volts across that. I think I may have to use other methods to test this. Okay, so that's up to 36 volts. I'm going to try swapping the polarity. Wind that way down. Just in case it's a single polarity of the LED, but I think it probably is inverse parallel LEDs, but there must be a lot of them. Yeah, that's. I think I'm going to have to hook this up to the mains with that resistor in line. Alright, on goes the soldering iron. And we can measure the voltage across it once I've got it hooked up to the mains. What an interesting little LED. Looks like it really is just designed for this task. So I shall get a couple of leads. I shall cut this in half, strip it and stick it into the mains. I'll solder this end to this resistor. Yes, we will be keeping the resistor in circuit. And maybe just tack one of the leads straight onto the LED actually. Solder iron has just come up to temperature. So I'll just tin those leads. Tin the resistor. I could do it without the resistor, but that would probably result in a bit of a bang when the LED was powered up. Now, I don't know if I'm actually better just not soldering onto this or not. Well, I've started, so I'll finish. So I'll just put some fresh solder onto that and tentatively tack this lead on. And tin that lead in, stick it on the resistor, and then we shall hook it up to the mains. Okay. Here's the test block. Just swap leads here. And let's connect this in. So let's put this here and this here. And power it up. Okay, so there's our LED. It's quite bright when you look at it. Let's grab another random meter that comes to hand, which is the fluke in this instance, and I'm looking for the AC voltage across the resistor. That's odd. How many LEDs are in that? 48 volts across that resistor? What on earth is in this chip? Yeah, so it's about 200 volts across that LED array. That is most unusual. That is really weird. I was not expecting that. I don't know what's in that. I don't know if it's just a solid mass of tiny little LED chips. Really surprised. 50 volts. Let's check the resistance of that again. Oops, get a good connection. Yep, 6.1 K. I equals V over R. 50 volts divided by 6100. About 8 milliamps at the voltage across that LED array. That is just weird. I haven't a clue what's in there. I think I may have to experiment a bit more, and what immediately comes to mind is maybe sticking a very high value resistor in series of this. Maybe like 1 megohm and just seeing what that looks like. I'm just going to go and grab a 1 megohm resistor. So here's a 1 megohm resistor. I'm going to stuff that into that terminal and then I'm going to twist the wire onto it. And see how bright it's going to go. It looks like 3 LEDs in that. No. I don't get this. That is an odd LED. I think I'm going to have to open this up. Is it got some sort of current regulator in it? Is it actually got a thermal, chip in there that's driving these LEDs? I don't know, I think I'm going to have to open this up. I'll be right back. Okay, you ready for this? Because I wasn't. This is a high voltage LED, and it must be designed for use in indicator lamps, control panel instrumentation and stuff like that. And it's radical. I've never seen anything like this. It's got this ceramic substrate with the circuitry deposited on top as layers of metallization, and then the chips physically placed on. And if you look at it in detail, these areas here are the metallized areas, including 3 islands in the middle for the LEDs, and some islands at the end for the rectifier, because there's a bridge rectifier built into it. And each of these is an individual diode. And the reason that at this end the diodes are directly mounted onto the supply is that these diodes must just be a fixed polarity, maybe positive in the bottom or negative in the bottom. Let's say it's negative in the bottom just for reference and positive on the top. In this case, the leads would jump over onto the top from these side pads onto the positives, and that would make that the negative. I don't know if it is negative or positive, but that's just for reference value. Whereas on the bottom here, these leads are connected to the bottom of the diodes, which are negative, and the positives go on the top, and they jump over to this island here. And from here, they either jump onto this island, or I think they might actually jump straight onto the chip. Now, each of these LED chips is wired in series. It bounces across, and I'm not sure. I can see gold pads have been used on here, so obviously one connection at least is coming onto the pad and then bounce onto the next one, then going across. So they're basically connected in series. And if you look at these LEDs in detail, they look like this. It's a 5x5 grid, and these are tiny. These are just about 1.5 millimeters square tops. I don't even think they're that big. And on it is an array of 5x5 positions. And you've got a circular pad at one corner and a square pad at the other, and this is obviously for polarity indication. And then these, I'm guessing that these areas here must be the LEDs. I'm not 100% sure. I think they are. And basically speaking, they're all connected in series in a zigzag style because there's a little electrode at each end, and then they're just jumped across, and then it jumps across sideways, and then it jumps all the way back and then sideways, jumps down, and it just zigzags. So they're basically connected in a big series string. And I'm not sure if this is an active LED area or not. I'll just guess it's not, but that would give 15, 16, 17, 18, 19, 20, 21, 22, that would give 23 chips. And if you do the maths and say each of those chips is roughly about 3 volts. I don't think it will be right up at 3 volts. But say 23 times 3 volts gives a voltage per LED of about 70 volts. So times 3 for all of them is roughly what we were getting when we tested it. And the rest of that voltage is just dropped across the resistor, which in this case was a 6.2K resistor. Blue, red, black, brown band with the tolerance. So that's quite radical. Suddenly it's quite an impressive little lamp. It does mean that the voltage across the resistor and the current means that resistor, it's not being hugely driven. It's been driven just under half a watt. But it still means that the end of the lamp was getting pretty hot. But I suppose that does keep... I mean, the fact that so much of the voltage is being dropped across the LEDs means that the LEDs and this ceramic substrate will get quite hot, but then it's coupled into the glass by just basically a press fit, I think, or I'm not even sure how tightly that was in. But yeah, very impressive. Really, really surprising. I just wasn't expecting that at all. And as I say, I'm guessing that it really is just designed for instrumentation lights and control panels, and they've just repurposed it into a pygmy lamp. So yeah, very interesting indeed. Suddenly it's an interesting lamp now, and I've just learned something tonight. So a little bit more, since this is currently my favourite thing. It says on the package power 1.5 watts, and you know what? It does work out roughly half a watt per chip in this. So in that sense, the dissipation isn't really extreme. if you consider that's just 3 half-watt chips, it means that, you know, this ceramic array is probably going to take that heat away quite well. The dissipation from the little resistor was about 0.4 watts, which is hotish. You know, I kind of prefer to run things a little bit lighter. I'd rather they'd use a slightly bigger resistor in there. But it made me wonder. Oh, and another thing about this is that makes sense now. Without the drive power supply for new high pressure product, the Chinese sometimes use the word pressure for voltage. So basically what they're saying is it's not got an electronic power driver because it's a new high voltage product, and they're referring to the LED that is capable of, it runs at about the best part of 200 volts. So then it had me thinking, if I was using this as an indicator lamp, how bright would it be if I brought the power dissipation down to the equivalent that you could use a 1/4 watt resistor in here, but only run it at half power? And I'd thought, let's see how low we can go. So here's two 10k resistors stuffed into the mains in series. So combined with the resistor in here, that will give about 26k. And as you can see, the lamp is actually visually, it's amply bright enough for a panel indicator lamp, more than bright enough for a panel indicator lamp. And then when you do the maths, it's dropping 50 volts across the resistor. So now that's going to be a total of 25k. So 50 volts divided by 25,000 ohms. Oh, that was wrong. P equals IV. No, let me think. I was looking for I equals V over R. So that's 50 volts. Yeah, that was right. Divided by 25,000 it's about 2 milliamps. And if you then multiply the 2 milliamps times the 50 volts, you end up with a power dissipation across the resistor of just a tenth. Yes, a tenth of a watt, 100 milliwatts. And then if you then multiply the dissipation of it's 200 volts across the LEDs times that 2 milliamps, then the LED itself is still dissipating the best part of half a watt. So I'm guessing that maybe these have been created for use in the instrumentation and equipment control panels for the indicator lights. Certainly it's quite radical. I really like that. It's been such a surprise playing about with that and finding out, and I was totally wrong. I just thought that it was the, you know, cheapskate Chinese. I expected to see a rough arrangement inside, like a wee rectifier or maybe the cob with a cluster of LEDs and the resistor, but I was totally wrong. Technically speaking, it is a cob, but it's just I was not expecting that number of LED chips. How many LED chips? It was 23 times 3. 69 LEDs in that. That's just absolutely amazing. Yeah, definitely. I'd like to see these in colours. That's quite radical indeed.